So we are going to dive into the kinetic theory of gases and then move on to liquids. So first thing, when we talk about the kinetic theory, when we talk about kinetic, that means motion. So we're talking about the motion of the matter. We're talking about the motion in solids. We're talking about the motion in liquids. We're talking about the motion in gas. So kinetic theory of matter is just talking about all of these particles of matter that are in motion, whether that's tons of motion going on or small parts of motion going on. So as we talk about first the kinetic theory of gases, they are crazy. They're just in a state of chaos, meaning that there's just all these tiny particles that are far apart, and what happens is they move independently of each other and they try to spread out as far apart, and what happens is they're moving so fast that they start to randomly collide. And when they randomly hit, they start going fast now in a different direction after they hit the object or hit the other particle. They just change direction. So it's just constant chaos and the particles are just moving everywhere. And all collisions that occur are elastic. That means they don't stick together. They just hit and then go in the other direction. So what happens with all of this is kinetic energy is just transferred from one particle to another as they hit and change directions and collide and change directions. It's just the energy of motion just keeps getting transferred between the particles. So what happens is collision of gas particles increases, it causes pressure. So as the increase of collisions occur, then pressure should increase. When gas pressure is equal to 0, then we could safely assume that there are no collisions occurring. So when we specifically talk about pressure, we hear the word, or we hear ATM, and that is talking about atmospheric pressure. And this is just the pressure that's caused by air in our atmosphere. And there is another video you can look at prior to this to help you calculate or convert from this standard pressure compared to the others, millimeters of mercury or kilopascal. So now we're going to talk about the kinetic theory of liquids, and kinetic theory meaning the motion of the particles in the liquid. So what happens is liquids have a intermolecular force of attraction. So they like to be closer together. They like to slide past each other. They have the ability to flow, but they're not all crazy like gas particles. So they're slightly compressible. So when we talk about the movement of these particles, liquids tend to evaporate eventually if left out. So the way this evaporation is when a liquid changes to a gas. So a particle must have enough kinetic energy to overcome that force of attraction. And so once it does, it releases. And as particles leave that have high kinetic energy from the liquid, that causes the average kinetic energy of what's left over, that liquid, to decrease. So the temperature decreases. So those particles in a liquid, the ones with the highest kinetic energy, are actually at the surface. And once those evaporate, again, the liquid that's there ends up cooling down. As the liquid cools, the heat flows in from the surroundings to keep at room temperature. Because when we talk about heat always flows from warmer to cooler. Just like if you were to have an ice cube in your hand, that ice cube would start to melt because heat is naturally flowing from your hand, from your body into the ice cube.